The following is the video solution from JSDT Solutions. Question 10.1 says, in the diagram triangle, RST is drawn, and then we have line AB intersects RS and RT at A and B respectively, such that AB is parallel to ST. Prove the theorem which states that the line drawn parallel to one side of a triangle divides the other two sides proportionally. And they specifically are showing you that they want you to prove that RA over AS is equal to RB over BT. Okay, so with this proof, we first have to sketch down some construction lines. So to prove this theorem, focus on RA and AS, but we're going to focus on them as the bases of our triangles. Okay, so RA as a base of a triangle, if you're looking at this as that is the base, you need a perpendicular height. We're going to sketch the perpendicular height. So the idea behind this is you cannot use the proportionality theorem, but rather we're going to prove it. So we are going to use the areas of triangles. You see how RA and RB are both the bases, they can both be the basis of this triangle. Okay, so let's go ahead and start sketching. We will draw a perpendicular line from point B all the way to RA. So it goes like that, and it's going to be a dotted line, of course. And we can go ahead and call that H. So it's perpendicular to RA, and we can call it H. And then we'll draw another perpendicular line because we're going to look at RB as if it's the base of a triangle as well. So it's going to need a height. So the height of RB is going to go from A down, and it's perpendicular to RB. And we can call that K. That's fine. Let's call that K. Okay, so we've got heights in that triangle, and so we're going to look at that as that's the base and that's the base, and those are their respective heights. Okay, now we're also going to use some triangles down here because you see that we have AS and BT. So we're going to look at that as the base of the triangle. But the triangle that we're going to draw here is by joining B and S. So if we join these two, and then we'll make them construction lines, and you see how that forms a triangle with the base AS, but it has the same height as this triangle over here with the base RA. And then we'll do the same for this height as well. We'll draw another triangle that shares this height down here. So by connecting A and T, and then make those construction lines as well. And again, this triangle has a base of BT, and it is sharing this height of K. Okay, so now we have to just write down all the constructions that we have made. Okay, so now focusing on these triangles, we will focus on these sides as the bases of the triangles, and we're really just trying to ensure that RA goes over AS. So we're going to use their areas. The area of the triangle with the base RA and the area of the triangle with the base AS. Okay, so that's going to be this triangle RAB, and the second triangle we're going to have there would be this triangle ASB. That's the one with the base AS. So it is the area of the triangle RAB over the area of the triangle ASB. Okay, and this is not equal to anything. It's not equal to any area over another area yet. We're just simply finding it and finding what it gives us. We know that the area of a triangle is equal to a half times the base times the height. So let's look at the base and the height here. In this triangle on top, the base is RA. We're trying to ensure that that is the base. And the height is H. So this is equal to a half multiplied by your base, which is RA, multiplied by your height, which is H. And this goes over this triangle ASB. Looking at that triangle, this is the base, but do you also see that this is the perpendicular height? Because this is the highest point of the triangle, and if you go down to the perpendicular line, which is an extension of the base, then that is the height. This triangle is really just an obtuse triangle, and it's actually skew, and this is the height. Okay, and do you see at this point, when we do this, we're going to have things cancel here. So these two, the half and half would cancel, and the H and the H would cancel, leaving us with RA over AS. Okay, great. Now we're going to do a similar thing with these bases now. Okay, so we're trying to ensure that these are the bases of the triangles that we're focusing on. So again, with this one, because it's the same triangle, it's the triangle RAB, the area of triangle RAB, over the area of the triangle ABT. Okay, and then this is equal to, again, a half times the base. Now, the base here in RAB, we are focusing on RB as the base, and the base here is BT. But you can see their common height is K, just like we had with the H as well. So that's a half times RB times K over a half times, and then the base here would be BT instead. So a half times BT times K. Okay, so a half and a half would cancel, and K would also cancel because they're exactly the same. So this is now equal to RB over BT. Okay, great. We have those individually. Now, to make them equal, or really to prove that they're equal, we're not making them equal, we're only proving. With the first triangle, you see that triangle RAB and triangle RAB are exactly the same. So we can state that for them. So the area is exactly the same. So you can just say, therefore, area of triangle RAB is exactly the same as RAB since it's the exact same triangle. But here is the thing about the bottom ones. These bottom triangles, do you notice that it's this triangle over here and this triangle over here? These triangles lie between parallel lines. So, since they lie between parallel lines, they would have the exact same height. Okay, so if you extended this and you went from the highest point of the triangle and you went down to an extension of the perpendicular base, okay, an extension there, then you see that the height would be exactly the same over there as well. But that's not the only thing that is the same in these two triangles. It's also the base. AB is also exactly the same. So since they have the same base and height, their areas will be exactly the same. So we're just going to state that they're equal and tell them it's because of their base and their height being equal. So triangle ASB is exactly equal to triangle ABT because they have a common base. They were sharing a base, okay? As you can see, AB was the base now. And they have the same height since they lie between parallel lines. And just make sure to state those lines that are parallel. Okay, so if we can see that those areas are equal and those areas are equal, and we know that when we found RAB over ASB, it gave us this, and RAB over ABT gave us that. That means that we can therefore say their areas put over each other exactly the same. So we're really just taking this and we're saying it is equal to that as well. And since their areas are equal, we can therefore now conclude what they simplify to would be equal. This is finally equal to this. Okay, so their ratios will also be equal. So this will be RB over BT. And when we look at what they told us to prove, do you see that it's exactly the same? Prove that RA over AS equals RB over BT, and we have proven this. And that is it for 10.1. Question 10.2 says, in the diagram, O is the center of the circle. And then we have triangle PWS is drawn, and we have P, W, and S on this circle. So they're on the circumference of the circle. Then we know that OR is perpendicular to PS and PRS is produced to T. SW and OT intersect at V, so those lines just intersect at V. And then they give us some important information here. So they tell us that OV is to OT is 1:4. Let's go ahead and put those ratios down. When they put these ratios down, it's the same thing as them giving you this as fractions, really. Okay, they're just saying if you took OV over OT, it gives you 1/4, meaning OV gets 1 part and then OT gets 4 parts. So we can actually put that down here. So OV is going to take 1 part, meaning we can just call that A. So that is A. And then OT gets 4 parts. So this is A. And then that one can be 4A. Okay, so we've put that down. The first question, 10.2.1, is to prove with reasons that OR is to WS is equal to 1 is to 2. So this is a half, okay? Meaning OR over WS equals 1 over 2. OR is here, this, over WS. Interesting. Okay, so the minute they say that, they're saying this one will get one part. So let's say K, and that would get two parts. So let's just see how that is possible here. Okay, so at this point, we can actually see this because this is the center of the circle, this is a radius, and this is also a radius. So these two would be equal. And then here, do you see that we have a line from the center of the circle perpendicular to the chord? The line from the center of a circle perpendicular to a chord will always bisect the chord, meaning PR is equal to RS. And that's what we have there. So this is the midpoint theorem when you have this side being equal to this side and that side being equal to this side. Therefore, it means that the two lines are first parallel, and secondly, this OR will be half the size of WS. Okay, so we just have to write down everything. So let's tell them that OP and OW are equal and the reason for them being equal. Okay, because they are equal radii. And then these two are equal because of the line drawn from the center of the circle perpendicular to the chord. So therefore, this means that OR is half the size of WS. Okay, so we will say OR is equal to half the size of WS. And the reason for this is when we have that case, it's because of the midpoint theorem. So we have to state that. Okay, so remember that this is what they want you to prove in this order. If you're saying that OR is equal to half the size of WS, then this means if you put them over each other, you could just decide, let's go ahead and divide both hand sides by WS so that it looks like that, OR and then WS. So this is simply just going to be OR over WS is equal to a half, meaning OR is to WS is equal to 1 is to 2. And there we go. See, the same way we're able to express these ratios as 1 over 4 is the same way we're able to do that here. And that is answer for 10.2.1. Okay, 10.2.2 says calculate the length of PT if ST is equal to 15 units. So they want us to find the length of PT, this entire length, if we know that ST is 15 units. 15. Okay, let's get rid of these ones. And here, do you see that we are using proportions here? Along with proving that this is half the size of this length, we also would conclude that these two lines are parallel. So, do you see that to find the entire length of PT, because we already know what ST is, we just need this part. But the good thing about PS is that PS is made up of PR and RS, which are exactly the same length. So we can just focus on finding RS. If we find RS, we have found PR and therefore PT. Okay, so let's go. Because we've already put these down, it makes it much easier to find. So focus on finding RS. So we're going to say RS, and we can take it over another side that we do have, which would be ST. So RS over ST, and using the proportionality theorem, this is going to be equal to, since we took this, we'll have to take OV over VT. Okay, let's just get this straight with VT. Do you see that OV is A, one part, and VT would not be 4A. OT is 4A, meaning VT must be 3A, because you would say A plus 3A to get the full 4A. Okay, so let's just keep that in mind. So it would mean that we can use these proportions and we must make sure it's equal to the correct ratios. Okay, so RS over ST equals OV over VT, which we can say is the line parallel to one side of the triangle or the proportionality theorem. It's perfectly fine. Okay, and in doing so, just ensure that you state the lines that are parallel. So these two lines are parallel, OR and WS. Okay, so we know that we are looking for RS, so that one stays RS. However, ST is 15 units. That's 15. And we know that OV took one part of that line, and then VT took 3 parts, as we saw previously. So now we can finally solve for RS. So to solve for RS, get rid of the 15 by multiplying both hand sides by 15. So RS would be equal to, that 15 goes here, so it's really 15 over 3, which is equal to 5 units. So if RS is equal to 5 units, then we can use that to find PR since they are equal. We've already stated that they are equal, so we can also just therefore say this also means that PR is equal to 5 units because this is already proven. So if RS and PR are both 5 units, so that's 5 plus 5 plus 15, and so that gives you 25 units. So we can finally conclude that it's going to be equal to 25 units. Therefore, PT is equal to 25 units, and that is our answer. And that is it for question 10.